Hi, this morning I persuaded a friend of mine to install FreeBSD and have a good look at ZFS. And right now he's going to be very confused about what the heck a dataset is. So, without much further ado, ZFS introduction. What the heck is a dataset anyway? Okay, so I'm on a ZFS system right now. First thing, what the heck is ZFS? Well, it's not a filing system and it's not a volume manager, it's both. It's vertically integrated. The volume manager manages the disks and the filing system sits on top of it, and the filing system knows what's going on the disk layer, and the disk layer knows what the filing system is doing, and it makes a whole load of really wonderful things possible. Now, when you create a set of disks or just set up a ZFS system, you end up with something called a Z pool, which is the accumulation of all the drives that are part of the storage that you're dealing with. And on this system, I'm just going to list out the Z pools that are there. Z pool list. I know there's only going to be one of them, and it's ZR. That's the Z pool that I'm actually booting from, and you can see it's 10 terabytes or thereabouts. It's not a terribly big one. As usual, 90% is allocated, and that's all you can really say about that Z pool list. If you want to get more information on it, you can do Z pool status, and it'll show you the geometry of it a bit. So down here we've got ZR, which is the name of the pool, and it is a level 1 RAID, so that's one disk's worth of redundancy, and it's made up of those individual disk devices there, all of which are online, all of which have no read, write or checksum problems. So yeah, that's cool. But I'm not going to mess around with this because it is a live system. I'm going to create a new Z pool for us to monkey around with, basically. So, how do you create a Z pool? You use the Z pool utility. Z pool create. Now, you might see some texts on ZFS, and everyone wants to call their Z pool tank for some strange reason. Who knows why? Tank is like 4 letters. I like 1 or 2 letters because I'm a Unix kind of guy. So I'm just going to call this pool P. Why not? And it does actually make sense. You can call your pool anything you like and give it a sensible name, for goodness sake. So, you know, it might be a pool that you're creating for your accounts data, or for development, or backup stuff. Anyway, so you can call it whatever you like. It doesn't have to be called tank. So I'm going to create P, and I'm going to make it a mirrored pool, because I'm only going to put 2 drives on it, and they're going to be you don't need to specify it. So it's direct access 1, that's a SCSI drive, DA2. Now I know these drives are actually not doing anything. Do check with the owner before you add their drive to a Z pool, because they won't be pleased. It'll trash all the data on it. So I'm going to create it, and this is going to take, oh no, it didn't take ages. So if we do Z pool list, you can see we've now got another pool here. They're relatively small, 300 gig drives, and there it is, P. It's 300 gig of data. If we look at it again, Z pool status, there's a drive, there's a Z pool below it, but here's our one. It's called P. It's online, and it's the first mirrored one, and it's made up of DA1 and DA2. Okay, so that's how you create a Z pool. Not a big deal. You can add and remove drives to it. You can add blocks of RAID drives to it. You can do all sorts of really crazy things, but that's basically how you deal with it. Obviously, if one of those drives fails, it'll just carry on as if nothing has happened. You can slot another drive in, say, hey, please add this drive to the mirror. You can have a 3-way mirror, a 4-way mirror, whatever you like. So that's just briefly about a Z pool. Now, how do you actually store data on it? Well, you need to create a data set, which is like a directory. So I'm going to create a directory for myself, and that's done using the ZFS utility, which is the one you use most of the time unless you're actually managing the pool. And I'm going to create one called P Frank. Hey, that's me. I'm going to create myself a data set there. And if I do ZFS list, whoa, there you go. There's the stuff on ZR and there's the stuff on P. So there's the root of P and there's P Frank. Now to limit what gets listed, you can actually specify the data set you want. If I do that, okay, I've disappeared from that, so you make it recursive with the -r, ZFS list -rp, and that is listing all the data sets that are on the Z pool P. So I've got P Frank. Let's create a few more. ZFS create, let's have Tom, one for different users, Dick, and Harry gets too many data sets, so I'm going to make this one for Sally. Okay, so if I go back and have a look at the data sets that have been created, there they are, and you can see the amount of data that's been used. Obviously there's not much in them. That's metadata. There's quite an overhead with ZFS, but it's a worth it overhead. And this is where it's mounted. So it's mounted on the Unix filing system tree, wherever you want it. So I can go to /p/ and that has default decided to mount it on /p/ Frank. So I could use it there, but it's not terribly convenient. Now, what is the difference between a data set and a mounted filing system? Huge amount. Okay, so one of the things, a data set has its own special attributes. So if I have, if I get the attributes for one of these data sets, let's say P Frank, you supply the name of the attribute. If you type in all, it gives you all the attributes, which is probably going to be more than we want here, but here they are. So its type is a filing system. It stores its creation date as one of the attributes. Isn't that fun? Some of these are interesting. There's the compression ratio. You can have a data set automatic compression on it. This one hasn't. I haven't enabled the compression, but I could do. You can have a quota on it. To say, you know, if you're doing home directories, you can say, well, each user is allowed, you know, 500 megabytes and no more, and that will not allow that data set to go more than 500 megabytes. There's another one down here, reservation. You can say, well, if the Z pool is, you know, running out of data space, this is a really important data set, and I want it to have at least 500 megabytes in, so you can reserve 500 megabytes even if you're not using it at the time. You can fiddle around with record sizes. I'll come back to mount point in a second. There's the compression. You can see that it's off. That's whether it records the access time. Not usually a great idea. Are you allowed to run stuff from it? Can you run set UID programs from it? A security feature, you could turn that off to make sure the data, no one can run programs that use the set UID feature. Is it read-only? You can make a dataset read-only. No one can mess around with it. Access control lists. Copies is a good one down here. It's keeping one copy of it. If you say this is really important data, please, you know, ZFS, could you keep 3 copies of this just to be on the safe side? It will keep 3 copies of it. There'll be an overhead as you write to it, but it'll keep 3 copies of it, and it'll try and keep them as far away from each other as possible, on separate disks preferably. Is it case sensitive? Yeah, all good Unix stuff is case sensitive, but you can turn that off on a dataset by dataset basis. Useful if you're using share SMB stuff, so your Windows users don't get confused. Other stuff down here. Ooh, well, I'm going to skip over that. I mean, there's lots of crazy stuff, and in fact, this is an old version of ZFS. On the new ones, there's even more. But if we go just scroll back up here to the mount point, and just to prove that you can do that, I'm just going to do get mount point. Okay, so its value is /p/frank. ZFS has done that for me. It's kind of useful to have stuff automatically mounted, but that's not where I want it to go. So I can change that. I can change ZFS set mount point. It helps if you spell it right. And equals /home/fjl. That's my real home directory, and I'm going to call it more space. Okay. Oops. I didn't tell it which it was. Silly me. P Frank. So that's where I want. And it's not going to let me do that because, as you can see, I'm actually in that directory. So let's see if I just move back to the root directory and run that command again. It will do that quite happily. So if I go to the FJL directory, can't run it. See there, ls. There's still a lot in here, so I'm just going to call it. Look for stuff beginning with M. There is my more space directory, and it appears just like any other directory. I can go into it. I can create files. There you go. You don't know that you're in a data set that's separate. It's very similar to when you've mounted a filing system on Unix. It's completely transparent to the system. The fact that it happens to be on a data set, it just happens to be on another data set. So, and I can create more data sets within it. Don't get confused, data sets are not directories. So if I create pfrank, I'm going to create a data set for my source, and I'm going to create a data set for my docs. Now, where do you think the mount points for those are going to be? ZFS is a bit smarter than that. So if I have a look at this, you can see that because I've told it I want more space to be in my home directory, if I create a data set that's a child of that one, it will try and mount it somewhere sensible. So I have got in my more space in my home directory, I have got what looks like two directories which are in fact data sets, or maybe they're data sets that look like directories, who knows, and they are pretty much empty. So let's see if I can, as you can see, so let's see if we can fill one up. So cp user source, let's copy everything in source to my source data set, make it recursive and give us something to watch while we're doing it. Whoa! Okay, so I'm now copying the system source into my own directory, making my own copy of it. And we could sit watching it copy the whole bally lot, but I'm not going to. So it's copied some stuff into that data set. If we now look here, the source data set is 73 meg long. The Frank data set is 74.5 meg long. So that is actually a sum of everything below it. That is what it refers to is what that particular data set, part of the data set is. And as you can see, that's 74 there. So the total we've used in the data set is 75. And most of it is stored there. Great. Now, apart from being able to set specific attributes on it, you can do some other crazy stuff with datasets, which is good fun. You can, for example, take a snapshot of it. So if I do ZFS snap p frank source at is it backup time? Oh, I don't know, evening. I'll just call it now. I'm going to call the snapshot now. You can call it anything you like. So the at means you're specifying a snapshot, and now is now, the immediate. Here we go. So that's made a copy of it. If I get a list of those snapshots, you won't see it. It's not there because snapshots are by default hidden. You can change that behavior, but at the moment they're hidden. So if I do type T for type all, it will list everything including the snapshots, and there is my snapshot. My snapshot contains 0 bytes because it is actually storing deltas. That's why it was created so quickly. If I go into source and let's see, whoa, I've got all of that stuff. What should I get rid of? I don't know. I'm going to get rid of all the make files, rm make files. I don't want those. Obsolete files.inc. Oh, read me. No, I'm not going to read anything. Yeah, let's get rid of all of them. Okay, so I've messed around with this a little bit. So if I have another listing of that, some of the stuff has gone. If I do our listing again, you can see there has some space has appeared in the snapshot because I've deleted 260k worth of files from the live version of the data set, but it has kept them in the snapshot. So those would be the deltas. Now, how easy would it be to restore a snapshot? You can actually look at a snapshot at the same time as the main one, but if you wanted to restore it, it's ZFS rollback. P, what did I call it? Frank source at now. So that is rolling back the snapshot, and if I have a look, hey, all my files are back exactly where I left them. Snapshots are really powerful like that. If you're going to do something wholesale to a system, just take a snapshot of it. If it goes horribly pear-shaped, just roll back to the snapshot. And you can have lots and lots of snapshots. I've just created one, but you can create a snapshot every day, every hour, and it's only storing deltas, so it doesn't take up too much space. And if you want to roll back an hour, you can roll back an hour. If you want to roll back 4 hours, you roll back 4 snapshots. It's not a big deal. Okay, what else can you do with snapshots? You can clone them. So let's clone this snapshot. ZFS clone p/frank/ source p/frank/ more source. Whoops. Okay, it's not going to let me clone the snapshot while it's live. It's mounted. Changes could be being made to it. People could have stuff open on it. So it needs a snapshot to clone. So I'm going to clone that snapshot. And now if I look here, I've got more source. And that's going to be a copy of source. But again, by cloning it, it is not copying every single byte of it. It is now forking the file system, and changes that are made to one or changes that are made to the other, it's only going to store the deltas. So that can be very efficient. If you're, for example, creating a virtual machine, you can clone the data set that the virtual machine is stored on 100 times, and it's not going to use up any more disk space. It's only when you start changing data on it that it starts using up more space. So this is really, really powerful, really, really handy. What else can you do? You can send and receive a data set. And when I say you can send a data set and receive a data set, you can always do this recursively, but I'm just doing it on a single data set. So ZFS send p frank source at now. Again, you have to use a snapshot because it's a live data set. I could unmount it, but I'm not going to unmount it. I'm just going to send the snapshot, so that's of a few seconds ago. And this writes it to standard output, except it won't let you because that's going to be garbage. But you can redirect it to somewhere. So if we redirect it to, say, a tape drive, I think there's a spare tape in there, dev, you could copy it to a file, obviously, serial access 0. Okay, so that's going to write that data set out to a tape. Tape drives take a little while to run because they're tape drives, but that's saving the data set to the tape. How big was it? I don't know. Oh, it's only 74 meg. That shouldn't take too long. Yeah, it's finished. Okay, how do we bring it back from the tape? Empty, wind the tape. ZFS receive. Again, this reads from standard in. P frank restored. Restore source. And I'm going to pipe that into /dev/sa0, and in it comes. So as I said, it writes to standard out. You could actually do a send from one data set, pipe it to receive from another data set, and copy your data set that way rather than cloning it. So that makes an actual byte by byte copy of it. You can see it's read the stuff in quite quickly. You could also pipe it using SSH to another machine on the other side of the world and receive it and store the data set that way. That's great. You can transfer a complete block of files at block level from one host to another to make a backup copy of it. But what's even more exciting is you can actually say, actually, I only want you to send the deltas between two snapshots, and it will only then have to transfer the data that's changed, and it can reconstruct the filing system, the whole data set on the other machine without having to transfer a whole lot. Microsoft DFS, rsync, eat your heart out. This system knows which blocks have changed and will only send the blocks that have actually changed. So let's have a look and see what we've got back. If we list that, there we go. So there's the one I've restored from tape. And guess what? It's exactly the same size as the one I saved. You can get rid of extra snapshots that you don't want. So ZFS destroy. Right. Okay, delete doesn't sound, you know, final enough. ZFS and Z-pools, you destroy them. So there we go, it's destroyed. Okay, I've still got the version of the tape, I've still got the cloned version, but that's how you get rid of things. So that's just a very brief introduction to some of the stuff that you can actually do with the data set. Key points to remember: it is not a filing system, it is not a partition. The data set can expand and contract inside the Z pool. If it needs more space, it takes it from the Z pool. If it frees up space, it returns it to the Z pool so other data sets can use it. It has its own attributes. You can mount it on the filing system in the way that you would normally mount another, you'd normally mount a filing system on another drive. And it's completely transparent to the operating system. And you can set up all sorts of fancy things like, whether it's case sensitive, how many copies are kept, what kind of compression you're using, and so on a dataset by dataset basis. And if you're having a particular directory and you want it to work in a different way, you create it as a dataset, and then you set the attributes to suit whatever it is you want for that data set. Quotas, the whole lot. Okay, so, and if I look at my Z pool list now, okay, my P data set has 150 allocated on it and so on. Guess how you get, most people never see a data set, a Z pool removed, but Z pool, guess what, destroy P. Bye bye, it's gone. Apart from the version I've stashed away on tape. Anyway, I hope that gives you some idea about what the potential of a data set is. Really powerful. Nothing else really like it. There have been a few attempts to produce this. I'm not going to tell you how it works in here. I'm not going to go into the details. It's a really deep subject, but that should be enough to get you excited. Hope you've enjoyed listening, and happy ZFSing.